If we're going to talk about polynomials, we need to get some vocabulary down pat. A term is a product of a number and variables. The number is always called the coefficient. The variables, of course, are those letters that are in there. It is possible that a term might not have any variables, in which case it is a constant term. Like 5. 5 is a constant term. Most terms do have one or more variables. They always have a coefficient. So if you see something like x squared y, the coefficient of this is basically 1 times x times x times y. So it actually has 3 variables in there. Now, a polynomial is essentially a sum of terms. So it could be a term or multiple terms. A polynomial can be written in its most general possible form as f of x equals sum a, the nth a times x raised to the power n, plus the next a down, so a sub n minus 1, times x raised to the exponent n minus 1, plus so on and so forth, where the a's are not going to be sequential. This just represents the coefficient. So that's a coefficient, that's a coefficient. The coefficients can be any real number. The exponents have to be positive integers or 0. So you say you've got a to the 7th, then the next one would be a to the 6th, a to the 5th, 4th, 3rd, squared, down to some a sub 1, x, which is understood to be x to the positive 1, plus a naught. The 0 suffix is usually read as not N-O-T, but N-A-U-G-H-T. And this would be times x to the 0, which is always defined to be the number 1. The degree is basically just the exponent. If you have multiple variables, it's the sum of the exponents. But with a polynomial, we're most of the time going to be talking about just one variable for the x's, and then you can have another variable or f of x for the y value. So the degree of any term is its exponent. The degree of a polynomial is the largest exponent. This is assuming it's just one variable. If it's written in the order such that you put the term with the biggest exponent first, and then the next exponent down, and the next exponent down, the next exponent down, so that they're written as largest down to smallest in order. That is called descending order. That goes from the largest exponent or largest degree to smallest, and that's the way you see them the majority of the time. Then the first term that you see is going to be the one with the largest exponent. That is called the leading or sometimes the dominating term. Regardless of what order the polynomial is written in, even if they're just put in there in random order, the leading term is always the term with the largest exponent. This term determines the shape of the graph. The other terms determine what kind of curves you've got in around the center, but the term with the largest exponent determines the shape of the graph, whether it is perhaps a parabola or something of a cube or a cube with all kinds of, this wouldn't be a cube actually, but it determines whether it goes up or down or opens up or opens down. All of this is always determined by the leading term. The leading coefficient is simply straight up the coefficient of the leading term. That coefficient determines what direction the graph goes in. Remember when we talked about reflecting, multiplying your biggest term, or your multiplying by a positive made it go up, a negative made it go down. A negative would reflect it across the x-axis or possibly around the y-axis. That has to do with the leading coefficient. So we've got term, we know what a polynomial is, we know what the degree is, we know what the degree of the polynomial is. We know what descending order is, or if it's smallest to largest, then that is called ascending order. You know that if you're descending a staircase, you start at the top and work your way down. If you're ascending a staircase, you're starting at the bottom and going up. Same kind of thing. Your leading or dominating term is whatever term has the biggest exponent. And your leading coefficient is the coefficient from the leading term. Some polynomials have special names based on what their degree is. For instance, if we just have f of x equals 3. Now 3 is just a constant, doesn't have any variables, so this is actually called a constant function. And its degree is 0 because we could write this as 3 times x to the 0, because that would be 3 times 1, which is still just 3. And the leading coefficient would be the 3 because that's all there is. F of x equals negative 3/5 x plus 5 would be a linear. The exponent is a 1, so the degree is a 1. The leading coefficient is the negative 3/5 because that's the one in the term with the biggest exponent. You're probably familiar with a quadratic also. Quadratic has an x squared as its biggest exponent, so it's a second degree. In this particular instance, the leading coefficient is a 1 because there isn't anything else written there, so we understand that to be a 1. Here's a cubic function that has an x cubed as its biggest exponent, so the degree is 3. In this case, the leading coefficient is the negative 5. An x to the 4th is called a quartic. Of course, it's 4th degree. In this particular case, the leading coefficient is the square root of 7. Even if this had been written as 4 plus square root of 7x to the 4th, this would still be the leading term. It would still be 4th degree, and the leading coefficient would still be the square root of 7. So those are the basics about polynomials. There's going to be more to come, of course, but first of all, we needed to get our vocabulary down right so we understand each other when we're talking. I will see you later. Take care.